this is number 28, page 113 of this. If you read it, it's two crates, one's on an incline 40 degrees. It's a smooth surface. That means in AP Physics terminology, it means there's no friction. So the question is, what's the acceleration of the 5 kilogram crate and what's the tension in the cable? Now to do this problem, we have a few things that are special because we're just going to make it simple. And one thing is we always use a massless, non-stretching string or cable. If it has mass or it has too much mass, then as this 5 kilogram box moves up and the 10 kilogram box moves down, you get more string over here, which adds more mass, and then you have a changing mass system. And if it's stretchy, then the tensions aren't the same. And we also have a massless pulley and frictionless. Because if we have a friction mass pulley, then there's something called rotational inertia, which also will affect the movement, and basically it resists change in motion, which is going to affect acceleration. So we ignore all that. And that makes it simple for starting out for sure. So basically what we need to do is we need to do two force diagrams. One for the 10 kilogram crate, one for the 5 kilogram crate. See if I get my pen to work here. Come on, pen. There we go. Alright. So let's start out with the 10 kilogram crate. So if I have a 10 kilogram crate, we're just going to do two significant figures. I know the problem has 3. I'm just going to do 2. How many forces are on this? Well, there's only 2. I'm going to use red for vertical and blue for horizontal. And there's a tension force up from the cable. We don't know what that is. And there's a gravitational force downward, also known as weight. And it is found by taking the mass times the acceleration due to gravity, which in this class we use 10. So 10 kilograms times 10 meters per second squared gives me 100 newtons. All right. That's all the forces acting on that one. The other box, so crate, we have, is sitting on this 40-degree incline, and it's 5 kilograms. And we're going to draw the forces on it. So one of the forces is two-dimensional, and it is straight down. That's the force of gravity again. Because what we've done is we've taken our XY axis and we've tilted it so that we have an X axis that goes along this way and a Y axis that goes along this way, right? So that makes this two-dimensional, and that's the force of gravity, and again, that's 5 kilograms, M times G, mass times acceleration due to gravity. That's 5 kilograms times 10 meters per second squared, which gives me 50 newtons. All right? The other force we have is a force along the tilted x-axis, which is from that cable, and that's tension. And then we have a force that's along the y-axis, and that is called the normal force. That's the force from the incline pushing up on the 5 kilogram box. Right? That is a 5 kilogram box. Okay. Well, what do we need to do? Well, one thing I need to do is I need to divide this two-dimensional force into a y force and an x force. And we know from geometry that the angle here is a similar triangle is equal to the angle of the incline, which in this case is 40 degrees. All right, so I'm going to say, and so my hypotenuse, this green hypotenuse is 50 newtons. And what I'm going to do is I'm going to say 50 times cosine, that's the red, 50 times cosine of 40. And if I do that, that gives me 38. I'll check it with my calculator here. 50 cosine of 40 is 38.3. So again, I'm using two snippet figures. So let's put 38 newtons. Well, guess what? That makes the normal force also equal, let's put it up this way, to 38 newtons. Those are, this part of gravity and the normal force are usually equal, and so in this case they are. Then the other one is 50 times sine of 40. And if I do 50 sine 40, then I get 32.13, which is just going to round to 32 newtons. Well, guess what? That 32 newtons is the force of gravity pulling this downhill. 32 newtons, right? So basically, we have a net force in the y direction on the 10 kilogram box, and we have a net force along the blue here of the 5 kilogram, and the y of 5 kilogram is opposite and equal, so there's no net force. So basically I have 32 newtons pulling it downhill, but I have tension pulling it up. Tension is an unknown. I have tension, oops, right here. I have tension pulling upward here in the vertical direction. And I have the force of gravity, which is the full 100 newtons pulling down. Well, as you can see, 100 is larger than 32, and there's no frictional force, so the 5 kilogram box is going to travel upward toward the pulley, the frictionless massless pulley, and the 100 kilogram or 10 kilogram box, 100 newton box, is going to go down toward the floor. And the question is, what's the acceleration? Well, we're going to use Newton's second law, which is this: sum of the forces equals the net force equals the net force, which equals film A. Alright? So let's just start out with the 10 kilogram box. And it's going to be T minus 100 newtons. Now, how did I get that? Well, that is the sum of the forces, because the P points up, 100 newtons points down. What I do with those two, they're point opposite directions. I subtract them, and we're going to say down is negative and up is positive. So it's going to be T minus 100 newtons. All right? And that equals, it's going to be accelerating downward. Downward's negative again, so it's going to be 5 kilograms. This is 10 kilograms. 10 kilograms, that's my mass, times the unknown acceleration, which is going to be a negative acceleration because it is moving downward. All right, let's just section this out here. Okay, that has two unknowns. It has an unknown A and an unknown T. All right, I don't know those two. Well, the other one is going to be T minus 32 newtons equals, what's the mass? 5 kilograms times, now this one is going to move upward, accelerate upward. That's a positive direction, so just put A, let's put a negative up there. Have to get all your negatives right and get it right. Okay, what I'm going to do now is I'm going to make this more simple by moving it all over here and just writing it without any units, so we can just see the math. All right, units are important, but we're going to just take the units out. I'm going to write T minus 32 equals positive 5. All right, two unknowns, got to have another equation. Well, that's where the other equation comes from up here in the red. T minus 100 equals negative 10A. All right, well, what I'm going to do, now you can solve and substitute. That's one way you can do it. But in this situation, what I like to do is just multiply everything by a negative. I can do that. And then I subtract. T minus T is 0. I just got rid of the T's. 100 minus 32 is 68. And then 5 plus 10 is 15A, just 7.15. And if you do that,
you're going to get 4.53, and I told you we're going to do two significant figures, so I'm going to just do 4.5 meters per second squared. If you want to use 3, that'd be 4.53. So that is one of my answers. The other answer is I want to find tension. Well, all you have to do is take that 4.5 meters per second squared and substitute in for your A. And if you do that and round off to significant figures, I'll let y'all do it. The answer you should get is 55 meters tension. Which makes sense because 55 is larger than 32, so it's going to accelerate upward toward the pulley. 55 is less than 100, so it's going to accelerate downward toward the ground. And if you look in your book, I think it's like 4.4 or something. That's because we use 10 and not 9.8. They got 53, I think, for tension. So using 10 as the acceleration due to gravity gave us slightly different answers, but that's totally acceptable on an AP test. And that's how you do number 28, page 113.